And now please welcome to the stage Mr. Anthony Mills, Executive Director, Founder and CEO at Global Innovation Institute Legacy Innovation Group, and Her Excellency Dr. Safa Nassereldin, Presidential Secretary General, Presidency Office, Assistant Professor at Faculty of Engineering at Al-Quds University, and Mr. Samir Talhouni, Co-Founder at Sagar Drone.
أول إشي يسعد مساكم وشكراً إنه ضليتوا للجلسة اللي قبل الأخيرة. يعني هاي دليل قديش أنتم متعطشين للتكنولوجيا والتكنولوجيا الجديدة. Good evening everyone. I'm so happy that you stayed for the before last session and before the closing session also. Our session, as our MC said, it's about cognitive versus smart cities and IoT. And we look forward for a better life for future generations. So His Excellency, the Mayor, was speaking about smart cities and smart Amman. But what about the cognitive cities? We will hear from our two experts here about the evolution of smart cities. It's not enough to have a smart city. Now, first we had the fourth industrial revolution, where we were speaking about Internet of Things, artificial intelligence, and so on. But now there is something very important that should be interfering in such decisions, which is the cognitive part, which is the human part. So cognitive cities should be more predictive. Before anything happens, we should have some prediction for any system we are working on. So the evolution of smart cities has been gradual, but we are starting new synchronization like that the Mayor spoke about in traffic, so that lights use Internet of Things, artificial intelligence, and clouds to collect data about the people, the infrastructure, and to improve the efficiency and quality of life. But the next step forward is the development of the cognitive cities, where we will hear from our experts, Mr. Anthony and Mr. Samir, about their experience in these two fields. Mr. Anthony, the mic is yours. We want to give you your presentation first.
Sure, thank you very much. Is my microphone on? Thank you very much. It's an honor to be with you. And I wanted to talk a little bit about, first of all, my vision, or the vision for cognitive city, what that looks like, how that's different than smart city, and then talk about a little bit about the challenges and maybe a few of the risks involved. And I think a lot of us here are concerned about the challenges for the path to get there. But first of all, let's talk about the vision. What is the difference between a cognitive city and a smart city? So, you know, a smart city is responsive in certain ways, but a cognitive city is actually much more adaptive. And the idea of the cognitive city is that it's collecting a significant amount of data from its citizens. Some of this comes directly from them, but a lot of it will come from devices and sensors and automation that collects data and then aggregates it. And the cognitive city is truly adaptive and predictively adaptive to what's going on in the city. And this happens at multiple levels. It happens on a citywide level. So in a cognitive city, it knows ahead of time what's the schedule for the local football team and when that's going to drive tremendous traffic to the local stadium. And it will adjust traffic flows in different ways through the infrastructure intelligently and predictively to preemptively deal with that and avoid traffic jams. So things will happen like that on a citywide level. And it will really know the flow and activity of the city, and it will adaptively manage the city to optimize things. And then as we move down to more the personal level, the cognitive city is truly human-centric. And part of the goal of the cognitive city is to truly be personalized. So each individual systems will personalize things to the individual. And a lot of this will happen through awareness of our presence. So, you know, the idea I like to have is when I go into the mall knows I'm there. It knows who I am. It knows, it can direct me to stores I like to go to and sales that are happening in those stores. So it knows exactly who I am, where I am, what I'm doing. And if I go to my office environment, it knows I'm there. It knows how to adjust the environment for me to my liking. So it's a very personalized environment. This happens in our homes. This happens in our offices. This happens in the public setting, that it knows who's present in a setting. And even in a public setting, it will know everyone who's there and what, to some degree, what they're doing. And it will try to customize and optimize the environment for that group. So as you can see, there's a lot going on behind the scenes to try to make this a reality at these different levels, you know, the citywide level, the individual level. But that's an important part of the smart city, is truly making it human-centric and optimizing everyone's life in the smart city. And a lot of that's happening by collecting a lot of data about us. And if we can get to that point where truly it's a frictionless environment, it will significantly, you know, increase the quality of life for everyone. Now, there's some big challenges on the roadway to get there. And one of the hugest challenges that we will be encountering is literally the proliferation of data. We deal with a lot of data right now in trying to set up things like, for example, smart traffic management systems. Those are very data intensive. But as we move from just a smart city to a cognitive city, that level of data is going to grow exponentially by exponentially. It's just the volumes of data you're dealing with are really mind-boggling, because what's going to happen is more and more devices are going to be sensorized, and the density of sensors in our devices and all around us is going to multiply thousands of fold, and each one of those is generating data. Let me give you a quick example. I live in Grand Rapids, Michigan in the United States, and that's where the office furniture industry is headquartered. Companies like Steelcase, Hayworth, and Herman Miller. And they're increasingly embedding sensors into the office furniture. But the challenge they run into is they don't have the ability or the capability and the resources to be able to process that data. So they're having to work with telcos and figuring out what pieces of hardware to embed to be able to handle and process that data. Now, all of this, when you scale this up to billions of sensors across, you know, millions of devices in a city, it's going to require very specific architecture from hardware, software, and data architecture to really be able to process this volume of data. Not to mention, of course, the AI element of processing the data, analyzing the data, doing predictive analytics, and really managing the city. And, you know, of course, there's fixed data, but more importantly, there's a lot of real-time data happening. So you imagine from a traffic management standpoint, you know, there's tens of thousands or hundreds of thousands of vehicles traveling the road at any one time. Well, this city is receiving data from every vehicle. Every vehicle is a smart city or smart vehicle, and it's aggregating this data through smart, you know, highway traffic systems, and it's aware of traffic flows at any given time. But any one of these vehicles could have hundreds of sensors transmitting hundreds of pieces of data in real time. And in order to do something that's safety-oriented like traffic management, it has to operate in real time. So the volume of data being transmitted in real time exceeds significantly what we're able to process right now. So there's going to be a bandwidth situation that has to grow. And I think bandwidth is something that's very relevant to everyone here. But the real-time bandwidth capacity to be able to do a cognitive city is an important milestone that we have to work toward to be able to process this volume of data from billions of sensors across the city, and then feed that into AI-controlled systems that will optimize the whole thing. So there, you know, I think we're many years off probably of actually realizing this utopia of a really good cognitive city. But of course, it's a goal and aspiration that we're working toward in a lot of cities around the world. And many cities have taken steps toward becoming a smart city. And I think that becomes the next aspiration for the next 30 or 40 years, is how do we really create the true cognitive city. And there will be things even beyond that if we have time, maybe we'll get into. But that's kind of my vision for the cognitive city and where I see a lot of the challenges lying. So I'll turn it back to you.
Thank you very much, Mr. Mills, for this introduction about cognitive and the difference between smart cities and cognitive cities and the challenges. So let's hear also our second expert, Mr. Samir Talhouni, who is a highly experienced business development professional and serial entrepreneur. I like the serial entrepreneur expression, it's very nice. And he's a co-founder of Sagar Drones and managing director at Blackstone in Jordan. And he's constantly interfacing with governmental and private sector institutions. And you will be surprised to know that he has a Bachelor of Law. So he's not our colleague in IT and technology and telecom, but he moved to our domain. So let's hear from Mr. Samir. Go ahead, please.
Thank you.
There's a PowerPoint for Mr. Samir, please.
That's it. Good afternoon, ladies and gentlemen. Building on what has been mentioned earlier, I think growing up between what we've seen in movies and what we read in books, this kind of represents one's imagination of the city of the future. An elevated city flying in the sky with drones flying, transporting people, delivering goods, really leaving not much room for human inputs to a degree of convenience possibly, but this is what you would have in your imagination set out, which could be the case obviously in 30, 40 years. We've seen that movies tend to dictate a lot of what happens in the future. But in talking about smart cities, I think it's also very important to try and understand the history. Smart cities don't necessarily need to be that futuristic. And if we take a look back at ancient Rome, for example, researchers have actually considered ancient Rome to be a form of a smart city. And this is potentially due to the fact that the civilization or the development within ancient Rome had occurred while maintaining the natural characteristics of the city as much as possible. So having a degree of sustainability to it. At the time, the economy of Rome had relied heavily on agriculture, and so it had a degree of sustainability there, surrounded by the riverbanks. It had plenty of farms, even within the walls of the city itself. And so it was actually self-sustaining in a sense that gives it the allocate of being a smart city. And I think that's a very interesting way to look at history, urbanization, in the sense that cities have always been smart, but moved to become smarter and smarter, up to potentially the topic of today, which is cognitive cities. And in researching the different meanings of what a smart city is, in trying to find the best way to coin the phrase of how do we make cities smarter, we found lots of wordings, lots of technologies attached to this notion of a smarter city, which is also very true. But to really be able to think ahead is to really get to the root cause of what a smart city is, and it is, in fact, managing the resources and the infrastructure of a city to best suit the requirements of its citizens and businesses. And I think if we think of it in that way, it becomes less of a label and it becomes more of a way of thought. It becomes initiative-based, objective-led, and I think the best way is to understand that there is no single playbook to dictate what a smart city should look like. I think Each country or each city needs to look at what it needs most, what areas of improvement the technology allow it to solve, and really start from there. So you would find potentially cities that have unbearable traffic jams looking to automate traffic management. Others which have potentially high crime rates would look at public safety and enhancing the security. And so I think smart cities have offered a lot of areas of improvement, from government services to water and power and infrastructure, and this is just to name a few. And excuse the font, I don't know what happened in sending the email, but looking at the enabling factors, I think it's very important when looking at digital cities and how that works within the smart cities. There are some infrastructure requirements. And with that infrastructure requirements, prominently is the development of 5G, the consumerization of 5G, and being able to deploy it in a way. And that's in the first pillar, which is connectivity. I think this is the game changer for being able to connect at a granular level in real time. And this will have to be an effort that is fueled by governments, but then also private sector, and looking at the different financing models that can enable this from happening. Sensors, and I think within IoT, if you really want the best case scenario, you would have to censor everything. Find ways to censor infrastructure, create as many nodes as possible, from streets, roads, infrastructure, buildings. So really looking at censoring the built environment. And computing is where it allows all of this to be bundled together, analyzed, processed, and ideally having lessons learned to reach to a cognitive state of a city. Digital twins, coming from a drone company and a drone background, one has to speak about what a digital twin is. We look at it from a site level, digitizing assets, and I think in the concept of a smart city, if you wanted to have a granular bird's eye view, one cannot have an optimized smart city without digitizing the city itself, or starting with digitizing the assets. This is the intersection of real physical life and the digital life. In the digital world, you're able to interact with assets in a better way. You're able to simulate, you're able to plan accordingly, analyze the outputs, and really manage over the lifetime of the asset in an efficient way. So on a site level, this is a resemblance of a digitized cell tower, which is relevant to this topic today. But then I think the objective is to look at a digitized urban city. And this is where you find the room open for that level of connectivity and reactiveness. Autonomous systems, I think, will play a major role in completing what a smart city is. We're seeing autonomous systems or unmanned systems, whether they're aerial, ground, or underground, being used in a variety of ways for inspection, gaining analytics, analyzing terrestrial data. But as we move along with smart cities, I think autonomous systems become an actor that autonomously take action based on a certain insight, based on a certain incident, and really start finding it in logistics, finding it in mobility. And based on that, I think it's very important to look at how we plan for this. What does the infrastructure look like? I think to the left is the typical thought we have about laying infrastructure. It's normal construction work in building roads, preparing connectivity between urban cities. But as we look at a new future of connected systems, of drones, unmanned systems, it's very important to also bear the fact that there needs to be an infrastructure in this mid-space to be able to synchronize the movement of systems, the movement of drones, make sure that there are no collisions, and be able to really solve the problems that we've been having, for instance, in emergency response, in incident response, and in logistics and mobility and what have you. And I think this is part of what we as a company have been contributing to at Sagir. We've been building a unified visibility system of systems that not only handles our digitization efforts today, but really set the stage for our preparedness to cater to the cities of the future, to cater to smart cities. Data scattered, unorganized is useless data. Unless the data is centralized in secure systems that is able to scale, that is able to view and able to manage all the different nodes and view the data, I think you don't really optimize what a smart city should be like. This is not exclusive to companies operating in drones. Everyone and every industry needs to think about how they can become relevant to a digital world, a connected world. And I won't take any longer. Thank you so much.
Thank you very much, Mr. Samir. You gave us a complimentary presentation about smart cities. And I want to go back to Mr. Mills to tell us about the technologies. Mr. Samir spoke a little bit about the systems needed, but what technologies are needed for coverage, or for example, in a cognitive city? As we said, cognitive is more predictive than smart cities. What do you think?
Yes, there's a number of technologies happening on a number of fronts, and to also talk about the technology, you have to talk a lot about the architecture of the whole thing. And there has to be a certain federated architecture to it, because obviously the flow and control of all this data can't all happen in a centralized way in a monolithic system. So it has to be a very federated approach. And so, of course, on the very outskirts of this, you're going to have this cloud of billions of sensors sending in billions of signals, and they're going to have their own processors, and there's going to be some processing that happens in the local out on the edge. And then some of that gets filtered and some of that gets sent in to the next level. And that next level may do certain processing at its level, and then it may pass along other processing to a higher level, so it's going to filter that. And eventually that gets to a central system. So you can have a central system with a federated network of other systems, and that just fans out into a network pattern. But a lot of the technology itself is really going to be all of this information, all this data coming in to different systems that are using largely artificial intelligence to analyze the data, to make decisions, and then to take actions. So it's actually going to be taking specific actions based on decision criteria and algorithms around that data. Some of this AI and the decisions and it's making and the actions it's taken, some of it will be happening in a centralized brain, if you will, for the city, but other decisions at different levels will be happening in a federated way out at different nodes and out to different devices beyond that. So there will be this hierarchical structure where there has to be a lot of communication between the nodes and the architecture. And ultimately, though, it's the AI embedded at the central level and embedded at the node levels that is making a lot of these decisions and taking a lot of these actions. And it really has to be high-capacity AI and explainable AI in a lot of cases, particularly where there's legal or safety implications. It needs to be explainable AI. We need to be able to understand why it's making the decisions it's making and how it's making those decisions. And it will make those decisions and take those actions at different levels, and that will be orchestrated. And the end goal of all of that these technologies work together, and the part that really excites me a lot is it actually results in tremendous amount of balance in the urban environment, and which is to translate into being more energy efficient and therefore more sustainable. Because now we deal with energy peaks, we deal with traffic peaks, we deal with demand peaks and all sorts of things. And a truly intelligent AI system like this is able to look at patterns that happen on a daily and weekly basis, as well as knowledge of special events happening. And it's able to balance out individual people's lives and activities and flows in the city so that you can smooth out a lot of these peak demands of energy and traffic and so forth. And it results in a much more efficient balance and therefore a more sustainable city. So that's exciting, but it really comes down to a lot of the technology around AI, the computing systems, the obviously the data transmission infrastructure, the sensors and the devices themselves. So there's a lot of touch points along the way, and there's different pieces of hardware and different pieces of software along the way. So you can think of it as a chain of these different pieces along the way.
Thank you very much. Very insightful and eye-opening, I think, for me at least. I hope for the audience too. So, Mr. Samir, we heard from Mr. Mills about the systems, the AI, decision-making, the balance it helps. What do you think your unified system would do in all that? How are you using your data and so on? Can you tell us more?
Absolutely. So I think with what Mr. Mills had offered, bringing all these different sensors, whether they're mounted on a pole or mounted on a drone, or even sensors, ground sensors collecting different type of active and passive data, you're either collecting them for an asset, which is connected to an organization or a government, or at an urban zone where you're doing it on behalf of a municipality, for example. I think what a unified system such as Sagar Space does is it layers the different types of infrastructure needed to enable or enact a smart city on the one hand. It manages the workflow of the data from collection point up until processing, analytics, and then being able to display it back in a way that gives those insights. So if the sensors are, for instance, looking at a farm or an agricultural land, for instance, subject to what you find within that data, you're able to dispatch a drone system autonomously to only fertilize and spray the crops that need to be attended to, as opposed to arbitrarily spraying the whole farm. And so I think this is the notion of being smarter in the decision making, optimizing resources. This is in a nutshell.
Yes, thank you very much, Mr. Samir. So using all these technologies, all these infrastructures, all these AI systems, do you think we will arrive to a point where the city itself, because it will be sentient, it will itself feel what it's needed, it will be predictive to a point. Do you think it will do what to its own interest more than the human interest? What do you think?
Well, this is an excellent question, and it really gets to the heart of the evolution of AI itself. And we're going very quickly through different industrial revolutions. Every industrial revolution has gotten shorter and shorter and shorter. The fourth one will come to a point where it will end. We'll get to the fifth one, and that will be shorter than the fourth. And AI is a core technology that's happening, and the capabilities of AI, which again is the brains of a cognitive city, those capabilities are growing exponentially. And it is predicted, and I believe that we will reach a point where the capabilities of AI and the progress of those capabilities exceed human capabilities and exceed our ability to keep up with what its progress. That's where we talk about the technological singularity. The biggest point of that to me is we actually have a prediction wall. We beyond what we really can't make good forecasts because we don't totally know what AI will do at that point if we let it operate on its own. That's why, of course, we have AI ethics and guidelines and rules. But we talk at times about AI itself becoming sentient. So if we think about the cognitive city, the hub of that whole thing is an AI system, the central AI system. If AI systems can become cognizant or sentient, can a cognizant city become a sentient city? Is that the next evolution of a city? And then it becomes almost like the city becomes like a living organism in and of itself. And we really don't know exactly what such a sentient city would do, but obviously we'd hope that in the algorithms that go into building that are built the ethics that, and we saw that this morning actually, some of the rules when Omar Halandi spoke with us from NASA. We saw that some of the rules for the automated systems, and number one was always to keep human interest as first and foremost, right? So we would hope that we can embed those sort of rules into the algorithms and they adhere to that. But again, as that evolution happens quickly, it raises the question at least, can that sort of get out of control, if you will. Can the AI become sentient? Therefore, can the cognitive city become sentient? That's a question I don't really know the answer to, but I see that it's possible. I could envision it being possible. And if that were to happen, we have to look at what our recourses are, which essentially is a kill switch to turn the city off. So that we need to have that fallback.
Yeah. One last question to our expert, Mr. Samir. Mr. Anthony spoke about ethics and rules. What do you think we should have? We are gathering lots of data from people, maybe without their knowledge, maybe with their knowledge. What do you think? What do you advise us here?
Absolutely. I think this is at the heart of enabling smart cities and the next revolution. And I think smart cities without humans or without the human input are not so smart after all. And in laying the infrastructure or the groundwork, even at a regulatory level, it's very important for the smart city model to succeed is to have the general population buy-in. And by that, this would mean asking for granular consent on sharing information, being able to transmit the most intimate type of details about your whereabouts, your movements, your preferences, and all of that. And I think one of the more successful models that have been achieved is by potentially open sourcing this type of information. For such strong and invasive at times data gathering, it's very important to be open about what's being gathered, how it's being tokenized, and what's being used. And I think having that transparent dialogue gives better give-in because at the end of the day, if people are feeding in the wrong inputs to the systems, you're getting out wrong or misleading outputs. And so this is a very, very important element. Another thing is with programming for these systems. I think there is a very big responsibility on companies and developers looking at developing solutions in autonomy. And one of the nicer questions I heard earlier is for autonomous vehicles. If a car had to either drive into a valley and kill whoever's in it, or the next alternative would be for it to run someone over. How would it act, and what should you insinuate to the machine to do? So I think ethics is a very important topic, and along with privacy and security, of course, that's another important issue.
Yes, thank you. Very important issues that we have to tackle, and I think in the Arab region we are missing some of the rules and regulations for ethics and what you said about privacy and so on. There are some countries working on their laws, but it's not enough, I think, to coexist with all these new technologies, I think. So we don't want to take more of your time because they gave us more than once assigned to finish, but we will say at the end that cognitive cities are proactive and predictive. It uses technologies to predict what's happening. So I think it's an advice for people not only to stick to smart cities, but think about predictive and cognitive cities, because smart is reactive, but cognitive is proactive and predictive, and we need it to our systems. Thank you for your listening, and looking forward to see you in 2024. Sheikh Nidal. Thank you very much. Thank you. يعطيكم العافية.